Automated attacks against public-facing web, mobile, and API-based applications can result in fraud, theft, lost sales, reduced customer confidence, and infrastructure cost overruns. These attacks appear to be legitimate transactions, hiding in plain sight, making detection and prevention an ongoing security challenge. What can your organization do to protect itself against these cyber threats? Hello, and welcome to this live audio webcast titled Finding Attackers Hiding in Plain Sight, brought to you by Sequence Security and IDG. My name is Tom Schmidt, Digital Content Director at IDG Strategic Marketing Services, and I'll be the moderator for this webcast. Joining me is Jason Kent, hacker in residence at Sequence. Jason has a diverse information security, networking, and IT background with knowledge about most of the pieces of the IT spectrum, including firewalls, security architecture, security controls, and security infrastructure. Hello, Jason.
Hey, how you doing?
Great. Before we get started, a quick word about this webcast. We're live today, and we welcome your questions and feedback. You can ask questions of our speaker during the Q&A segment of the webcast by typing them into the Q&A box on your console. We'll do our best to answer all your questions, but if we can't, we'll get back to you with an answer within a few days. So Jason, let's kick things off by telling our audience what you plan to cover today and maybe a little bit about the demo you're going to be showing later in the presentation.
Sure thing. So I'm going to be going through just a couple of items around what it looks like to be attacked by these bots. What do they really need? What kind of care and feeding does a bot take in order to go attack your infrastructure? And we're going to talk a little bit about how you can find these bots going, as they attack you, utilizing some of the tools that we have in our arsenal. I'll do a demo. I'll admit the demo's recorded as we're in lockdown and things are a little bit uncertain. I wanted to make sure that piece worked. And inside the demo, I'm going to show you how we find these things and what it looks like to stop them from attacking you. So,
great.
Oh, go ahead, Tom.
So Jason, let's get to the heart of the matter. Tell us what we need to know. What do we need to know about bots?
Well, sure. First thing I'm going to do, though, is go through a little bit more of an introduction of myself. My name is Jason Kent, and as Tom said, I'm a hacker in residence here at Sequence. I've been doing application security projects for a little over 20 years. I got introduced to SQL injection back in 1998, and I started really paying attention to application security when my wife worked at a bank and I worked there as well. And I was really curious about all these web applications that were being written, and I really wanted to start digging into it. That carries forward in my career to a place where I started poking around with APIs and mobile applications, and I ended up breaking into the Chamberlain garage door opener app. I opened my garage door, then I opened a friend of mine's garage door that was about 2,000 miles away. I live in Columbus, Ohio, and I'm currently on lockdown. My university student and my high school student are both here waiting for me to turn the internet back on to them, as well as my spouse. So we're enjoying all of our time together. I do a little bit of work with Hackers for Charity. If you guys don't know this organization, you can go look it up. But we enable technology and technology projects in third world countries and places where it's hard to sustain those things. We don't worry much about attack bots in those environments, though. So what we're going to do now is start looking for the bots that are out there. So I guess the first part of that is you have to define sort of what is a bot. To me, a bot is just some kind of automated software or group of pieces of software working together to accomplish some kind of goal. It's usually automating some kind of tedium. If you want to check to see if a username is valid on a platform and you have 1,000 usernames, you're going to need something that's going to iterate through each one of those usernames and then determine whether or not they're good or bad based on indicators that you might be getting from the platform itself. And there's all kinds of bots that are available to the world and that are out there. Some of them are good bots, some of them are bad bots, some of them I guess could be considered chaotic neutral. The good bots are examples of things like Slack bots that deliver you news about your company or news about a market or something like that. You may have bots that are going out and looking for things like links on websites, like the Google crawler or Yandex or whoever. You might have bots that are doing things for you to automate tasks to make your job easier. Maybe you run a vulnerability management program and you'd like to know, are the CVEs that were just released impacting me? So you might write some automated software to go do that. There's examples of bad bots as well. I have Slack bot at both columns. When I worked for my previous organization, I wrote a GDPR Slack bot. Anytime somebody said GDPR, it would say, have you updated your policy yet? And so, there's all kinds of things that bots do from a negative side as far as attacking you goes, things like account takeover, credential stuffing, looking at, taking over inventory, and something that we like to call seat spinning, where we have a bot that's taking over either tickets for a concert or tickets for an airline, and then somebody's reselling them, for a lower rate. It ties up the inventory, makes it unavailable to everybody, and oftentimes when this kind of thing happens, you end up in the news. But the anatomy of a bot realistically, looks like I have on the screen here, where you've got an attack bot that's being held up by its infrastructure and all the pieces that it needs, that's going through some kind of iterative cycle against an infrastructure. Now, this infrastructure could be your web applications, but more and more we're seeing that the API is a better place to attack. Web servers have to feed out a lot of code. The end user has to render that code and deal with it. It's true you can create a bot that just sends posts into a web application, but even then the web server is going to sort of gate everything that goes in, whereas in the API channel, it's meant for high-speed processing and high-speed transactions. So a lot of times we're seeing bots attack the API layers of networks and not touch the web application as much anymore, just simply because the API is more responsive. Basically, you've built a better attack platform, and you're getting attacked in the most efficient way that you can. Not sort of the way everybody wants to see the world, but it is exactly what's happening out there. So when we look at what a bot needs as far as sort of care and feeding, at Sequence, we've developed this concept that there are 4 pillars that hold up a bot platform. And so those pillars are really the sorts of things that you would expect. We need credentials, right? We're going to have authentication into this service. Now, whether those credentials are stolen or they're actually your registered credentials or your API keys or whatever that credential set looks like, the bot's still going to need them in order to authenticate and utilize this service. Next to that, we have tools. Tools can be a bunch of different things. I can go out and purchase attack tools for specific platforms. I can contact the authors of these tools and say, hey, will you write me a tool that will attack this thing in this way? Or I can simply write my own and spin up, whatever attack bots I'd like. If you look around on the internet a little bit, you'll hit GitHub repos all over the place, and even Docker repos that have all manner of bots inside of them, good, bad, or indifferent. To go along with the credentials and tools, there has to be some kind of infrastructure that will run all of this stuff. And so more and more for us, that means a proxy infrastructure. We fire the bots at a proxy. We let the proxy infrastructure exit the attack closest or furthest away, or whatever city, state, or zip we'd like to land in. The traffic can originate from there, hit the servers, and look like really legitimate traffic. And we'll dig into each one of these pillars as we go, but the infrastructure is kind of interesting and crafty, and I'll dive a little bit deeper into that. And the last is behavior. Bots are easy to see. And I entitled this Hiding in Plain Sight because bots are changing their behavior all the time. They look at the behavior of your application, your website, your APIs, and they modify what they do. If they notice that a certain user agent string doesn't get through anymore, they're going to change that so that rather than looking like an old version of Chrome, they look like a new version of Chrome. We see behavioral changes in all of the customers that we have that are running our product. We see this all the time. We call them campaigns when they start to really change what they're doing and when the attacks start to ramp up. And when we look at what's happening lately with everybody on lockdown and so many people and so much of the world is sort of sitting at home, we're starting to see attacks go up and up. And as economies are going to be impacted by this, we're going to see that rate go up even higher. And it's not just against financial institutions. It's bot organizations that are looking to defraud people. It's bot organizations that are looking to, obviously steal things. Or it's somebody that just wants to consume something that they just really don't have a right to or they haven't paid for. So let's kind of dig into this a little bit deeper. From the tools perspective, there are commercial frameworks that you can purchase out there. You may have heard of a few of these, things like Sniper, Sentry MBA. They usually float up to the top of the list, open bullets on there. And there's quite a few of these kinds of tools that are available. You just click and download and off you go. But there's also customized tools. There are hackers for hire, if you will. Really, they're criminals for hire that you can hire, and they will go develop a tool for you or develop an attack program for you. And all you have to do is provide then that infrastructure to run it on, maybe a credential set, and it'll go off and do its thing and hopefully benefit no one. But we see it benefiting people all the time. The commercial tool config that you'll find out there usually point at very specific things. So account takeover tools are very common, where somebody's just simply trying to take over either a social media account or perhaps something that has a content service behind it like Netflix or Disney Plus. And we'll see these attacks flow in against these organizations. They often come from these commercial tools, and honestly, the commercial tools have signatures, and they sort of give themselves away. And they are always changing. We see them when we go look at the commercial tools that are available on the market. We see them change with quite a bit of frequency in the way that they behave, in the infrastructure that they use, and you can provide your own credentials if you'd like. So if you happen to do a lot of financial services, you do credit card transactions, you're worried about bots, you should be. That's where the money is, and that's where the attackers tend to go. But other kinds of currency are also something that we see a lot of attacks on. People will generate their own like gift card numbers, and they'll attempt them against a site. If you're accepting a gift card on your site, one word of caution is that if the gift card doesn't work, it shouldn't be readily obvious for the bot. And the reason I bring that up is we often see people generate their own gift card number, fire that against an API, and they can do that over and over and over again and figure out gift cards that might work. They can infer gift card numbers that will function. and then use them to steal from people that should be getting those things. Keep in mind that all of these configs are pretty easy to set up. They're pretty easy to fire at a target, and if your target is high speed and very responsive, you can throttle it way up and make the attack really noisy and do whatever you'd like. These commercial configs, basically if you go to Google and you put in the keyword cracking, you're going to end up on cracking.org or cracking.to or a couple of these other places where you can go buy Sentry MBA configs. You can download free configs, and there are people that will make configs for you in these forums. They're fairly easy to join, and they're pretty happy to take on new members and even help you out if you have problems with getting something working. One of the targets that we see a lot of these tools shoot at are WordPress sites. So we see them attacking all different kinds of things, but also if you have frameworks, they might attack you there. And so people that have a WordPress site up and they leave their WP-admin page exposed and they have default credentials on them, the bots can take those over pretty quickly. And if any of you have a junk folder and you go look in your junk mail, you may see phishing attempts for things like your FedEx package couldn't be delivered, or you may see something wrong with your Amazon order or something like that. And if you hover over the links, don't click them, but if you determine what that link actually is, it almost, it's a very high percentage of the time, I won't say almost always, but it's a very high percentage of the time, those links follow to somebody's WordPress page. And what they're doing is they're using a bot to find the WordPress admin pages, and then they're using a bot to load some bad content on that page. They do it for a couple of different reasons. One of them might just be a place to serve malware out of, and the other might just be they're in competition with this organization and they want to do some kind of anti-SEO markers inside of the page. So they'll do stuff like Viagra ads on a restaurant website, for instance, and that'll drive the SEO weird because of it. So there's a lot of different ways these bots are used. Rewards programs and gift cards are something that we see a lot of, but we also see a lot of things like attacks against old APIs or dead APIs that are no longer used. If you go look at APK tools out there and take apart Android applications, you can see the API calls that the application is making. And you can go get backdated versions of the APKs, and so that means when you take the old ones apart, you're going to find old APIs. When I say that they're hiding in plain sight, the attackers are going against those old APIs, the old login pages, anything that they can, and they just look like an old user. But in fact, they're trying to find the places where you have and have not implemented security, and they can attack against those targets. Things like account functions are a really great place to instrument yourself and look for these attacks. Obviously, if I want to do account takeover, I've got to authenticate. So I'm going to go try to find your least protected authentication spot, and then I'm going to fire attacks at it. And I just recently did a blog post on credential stuffing where I looked at a target that I'm doing some research on, and it was telling me bad username and bad password in the API calls. Now, in the login endpoints that I was actually using to use the application, I didn't see that behavior. But in those old API endpoints, those things that should be deprecated, it was giving me that behavior. And this lets me set the tools up to work against the places that make the most sense to me. So that's an understanding, or at least a little bit of an introduction to tools. Let's talk about one of these other pillars. Let's look at infrastructure. What are the sorts of things that a bot is going to need? Well, it's going to need a computer to run on somewhere. The software has to run. It's going to need things like proxy network in order to spread itself out. Otherwise, the the small county government that you might work for suddenly sees an influx of traffic from Lagos, Nigeria, it's pretty easy to just block that stuff. But when I start coming from set-top boxes all over the county, well, then that's a little bit different story. So we see this infrastructure in kind of three different places. We see server-based infrastructure, we see static infrastructure, and then we also see these what we call residential or dynamic networks. The infrastructure itself is almost always some computer, right? That's obvious in how it should always work. But if we look at things like server-based infrastructure, these are computers that have been compromised in some way, whether that's they installed a piece of freeware or an attacker found that they had a port open, logged in, and dropped something on here to proxy off of. It really doesn't matter so much, but these are servers that are sitting in a data center somewhere. So they're high speed, they can handle a lot of transactions, and they almost always have big pipes coming in and out so they can move data at a pretty good clip. But when we look at other types of infrastructure that are out there, like static infrastructure, for instance, this goes a little bit beyond the servers, right? These are fixed points, and we tend to see these as like set-top boxes. They're usually a little less powerful, but they tend to be in the same networks. They tend to be doing the same things. And in our research, we found that there's a lot of ISP infrastructure that seems to be beaconing out attacks. If you were to, sort of look at this from a radar scope perspective, you would see these ISPs just pounding out attacks, and it doesn't really make any sense as to why they exist in the network, except for things like set-top boxes or pieces of critical infrastructure for the ISPs. And then finally, kind of the funnest piece of this, in my opinion, is the dynamic residential and dynamic mobile IPs. Literally, I can go to an organization, give them a credit card, rent time on this network, and we'll see my requests exit from all manner of devices. Could be a cell phone, could be a laptop. It's going to hit the ISP networks in all different ways. These are the guys that are doing a really good job of hiding in plain sight. But they're very expensive. One organization that I approached to purchase this service from was $7,000 for a year at 10 gigs of data a month, and then the prices went up from there. I found a $500 a month option that had about 15 gigs of data, but there's sort of I don't know, they're not very easily approached, and they don't take things like credit cards. So when you look at all these things, you start to understand there's a myriad of options out there for an attack to be originating from kind of anywhere in the world. What you have to look for is a combination of things, and that's the reason why that we have this all set up. As far as 4 pillars go, we have to have a combination of these things in order for it to work. So how come I kept saying things like freeware and compromise on each one of those, on the servers, the statics, and the dynamic mobile and residential networks? Well, this is just a simple example of this, but if you go look for, I don't know if it's Hala or Ola or Hala, I have never heard anybody say it, so I don't really know how to pronounce it, but it's HOLA.org. And if you go look at this, it's a VPN service, and a lot of people, firmly believe if I join a Wi-Fi network, I need to turn on a VPN. Wouldn't it be great if there was a free one? And sure enough, there is a free one. But you got to remember, when things are free, sometimes they cost a lot more. And in this case, if you use the whole VPN, you will end up on a network that's called the Illuminati proxy network. You, by downloading this and accepting the terms and conditions and installing it on your phone, laptops, whatever, you allow people to rent time on your computer to be a proxy endpoint. It's fairly expensive to do from the attacker's perspective, but if you've got a good attack going and you need some really randomized IP addresses, they have an entire infrastructure underneath that allows for you to select where you want the traffic to originate from, how much rotation you want, and all that kind of thing. So it's a really easy way for people to spread the attack out and make it look like you're just another end user interacting with the environment. So as we move along through the other parts, the other pillars, we'll look at behavior. Behavior, like I said, is the bots changing as they attack you, and your behavior as you respond to them, they interact with each other. And so if I see that you don't like a certain user agent string, or if you're setting some kind of time and you are timing me out based on that time, I'm going to learn that as an attacker and try to make as many changes as I can in order to realistically look like just another user on the network. So this is just a snapshot of Burke. You can see I'm getting a single item off of a web page here. So this is Ohio State's web page. I'm just getting the favIco, right? The little icon that shows up in the tab. This is a single request, right? So if I am a bot and I want to look like I'm not attacking you, what I'm going to want to do is slowly drip in the attack. The most prevalent way that we see this is with web scraping, but this can be done for all manner of attacks. But if you can imagine, I want to go get all of the new items off of my competitor's website. I'm going to make it look like I'm just requesting them one at a time. And it's going to have to be a fairly coordinated and orchestrated thing. And so the first bot is going to go out and they're going to go look for a resource. They're going to end up sending back to a command and control service the fact that that resource exists, and they're going to be sending back to that command and control service all of the other resources that they're going to learn about. And so once I see that I've got more than one resource, I can bring other bots online and make single requests for each one of them. So basically the command and control server is going to say, you go get page 1, you go get page 2, you go get page 3, and each bot will then pull everything back and compile it. Some of these bot authors have a little poetic justice buried into their stuff. Some of them have messages that they're trying to send out or whatever. We've seen attack bots that'll do single requests, and they'll do 1,337 requests at a time, which in elite speak says they're elite and they're the ones that are really doing the best. We see dynamic rotating behavior as well as that single request behavior. And what this is it's basically single requests, but the URL remains the same, right? So we see this behavior usually on older fingerprints, and we see it coming from kind of old school attackers that haven't kept up with the times. They're usually running off of a commercial tool, and it's just a config that they keep changing. There's behavioral avoidance that you have to take into consideration as well. Some of these commercial tools have CAPTCHA avoidance. Some of them have very sophisticated CAPTCHA avoidance where they will send a page off to a human reader, and the human reader will look at the page and say, yeah, that's, here's all the stoplights, right, or that word is this. And then they send it back. And it's very high speed and round trip. The Google service that, it'll say, I think it's called the reCAPTCHA service, it'll say, click this box to make sure that you're not a robot. That's an API call to the back end, and an API call return that can be automated. and it makes it so that attacking the website's a lot easier. Adding a CAPTCHA means that you're adding user friction. It means that you're going to make a user have to stop and do something. And, there's been bunches of times where I've had, the 9-block picture where it says, show me all the traffic lights, and there'll be a picture of a traffic light, but I'll be wrong, right? And so those kinds of things generate user friction, and they generate a need for a better service, or at least a better way. So we talked about, when I introduced the 4 pillars, I talked about credentials. But think about this for a second. Where can I go get credentials? Like if I want to go attack a service, how do I figure out what the usernames are that are associated with that service? Well, a good reconnaissance step is pretty simple. Sign up for the service. What do you accept as a username? What do you accept as a password? And then I can start guessing. Or I can start sending usernames at this thing and see how well it responds. I don't know if you remember when Disney Plus launched a few months ago, but when it first came out, it was like 24 hours, maybe 48 hours, and suddenly there were giant lists of usernames for Disney Plus. And what had happened was somebody started guessing. And they look at old dumps. They look at old lists that have email addresses in them, and they take every one of those email addresses and they try them. And they try to see, are you telling me it's a bad username, or are you telling me it's a bad password? And this is where information disclosure and having good practices around saying, well, something went wrong, but I'm not going to tell you what it is, can really help. So where do we get these credentials? Pastebin dumps, or insert whatever your favorite text dump area is. We see lots of them out there, but oftentimes they're just advertisements for much bigger lists and they have to pay for. Some of these lists are vetted, and some of the credential sets out there are simply just known. If you look at the old Mirai botnet, there were 61 usernames and passwords on there. And the majority of those things were things like admin and root. They were things that come as defaults on various things. And what they were attacking was the IP cameras, but they were just looking at the telnet password on those cameras. Pastebin dumps could be a good source. They maybe aren't, right? Could very well be you're getting the MySpace dump from the 90s. Or it could be that you're getting something a little bit better than that. But at any rate, you can almost always find big, long lists of credentials out on places like Pastebin. Vetted lists are usually people that curate dump lists. So they go get a big Pastebin dump, and then they go check to see, do I have valid credentials here? Spotify had a database leak out onto the network, and that database contained a whole bunch of usernames and passwords that were actually valid. And a lot of times an organization, when you're notified about these things, they don't do anything. Sometimes they do. But if you happen across study credentials for your organization, my recommendation is go flush everybody's passwords and make them put a new one in. Oftentimes the verification for these vetted lists is done by a bot. So like I said, known, admin, and any of those kind of default credentials that PCI says you're not allowed to use are often available out there. It really varies based on the target, and oftentimes is something that makes a lot of noise and is easily seen. So if somebody's rattling the front door of your web application and they're jamming administrator and admin into the username field, that's not a very sophisticated attacker. But there may be an underlying attack going on this is calling your attention to, and they're just simply trying to get you to look at it. So we're going to talk a little bit about what it looks like to look for threats. Right? So threat hunting is just simply going out there and looking for threats for sport or food. We're going out and looking for the bad guys, and we got to try to really get the information out to see them attacking us, unless you've got some automation that goes behind this. So if you can take the same concepts that they're using and apply them back against them, right? So we want to see behavioral changes. We want to make behavioral changes to see them make behavioral changes. We want to be able to identify when the attacker is coming at us, and we do this through an automated way. We've got some machine learning algorithms, and we've got some just signature-based stuff that's sitting in there that says, okay, when this transaction came in, it had a session token that was established in a different country from a different username, from a different web browser than that user usually uses. I think maybe this is bad, right? And so in order to do any kind of threat hunting, you have to have some knowledge of the underlying attack infrastructure, the credentials that they might be using, and all of the things that we've talked about in the pillars. And so in order to hunt these guys down, we have to do some fairly sophisticated things in order to really see them. Cyber threat hunting really is the process of proactively and iteratively searching, right, to detect the attacks. And that's what we do when the transaction comes in. We search for its intent. What are you trying to achieve with this transaction? And transactional intent really helps us understand where we might be able to get a hold of these guys. So I'm going to right now turn on a recording, and I happily admit that it's recording. As all of us are in lockdown, we had to change our lifestyles a little bit. So I recorded this a couple of days ago. I edited it, make sure that it would work, and I'm going to play it now, and we're going to talk a little bit about what it looks like to look for these solutions.
All right, so we're going to go ahead and take a look at the sequence security solution, or what we call CQAI. I'm going to take you through a little bit of a tour of the platform, and then we'll start looking at a few different things that will allow for us to hunt down a few of these threats and identify how the bots are operating. Keep in mind that I had to record this before the webinar, just simply because of the COVID virus and everybody's on lockdown. I have to do this from my home. I don't have the best internet connection. So pre-recorded means that you actually get to go through this and see everything. And I'm going to be able to illustrate what I want to without it crashing in the middle or me losing internet connection or something like that. So we'll go ahead and get logged in into the console. Once I get logged in, I land on a dashboard, and the dashboard allows for me to look at various different things as far as how the bots are operating, how much traffic is flowing through the applications that I'm protecting. It allows for me to look at some of the metrics around the bots that are coming after our application. The first thing that I like to highlight is the Discover. The Discover. If you look at the left side of this, you can see that we're starting to build sort of a sitemap tree. And this isn't a sitemap tree that's being generated dynamically by going out and scanning the application. These are actually the endpoints for web application, for APIs, etc., that are being touched. And this really allows for me to illustrate the power of sitting in line with this traffic that's going off to the application. It lets me see where the traffic is headed. And we can see in this, in the API selection, where the mobile app endpoints are and what's being exercised or attacked or utilized in some way. A lot of organizations have API endpoints for their mobile applications, but they don't have a way to enumerate them. They don't have a really good way to look at the API endpoints and how much traffic is going against them. And there are sensitive API endpoints that are out there that a lot of organizations may or may not want somebody to go up against. So for instance, we have account API activities that go back to a version 1 API, but there also seems to be a version 2 API that has account activities that are associated with it. Is this because we didn't deprecate version 1? Is version 1 being used someplace else? This simple activity of going and looking at the endpoints that you have allows for you to see, hey, we forgot to turn something off. And any time you look at security standards out there in the world, the first thing they're going to say is have an inventory. You can't protect the things you don't know you have. And many organizations have trouble developing the inventory of their API endpoints as well as their web application endpoints. And this really helps you do that. So going back to the bot detection, we can look at the information that's flowing in through this in kind of two ways. The traffic that seems to be normal, that looks like legitimate traffic, and then attack traffic coming from bots. Now in this environment, we've got our own bots set up and they're attacking, but this mirrors what a lot of our customers see. Oftentimes our customers are developing high-speed applications that allow for a lot of traffic to flow into them, and they keep setting that high watermark of traffic higher and higher because they're getting more and more attack traffic. So realistically, your operations folks are going to be interested in seeing how much savings they can have by simply cutting down the attack traffic that's coming across the platform and blocking it at the source. So as we scroll down here from the traffic volume statistics, you can see we have a way to pivot the information that we have flowing in. So I can switch this over to look at things like what countries are traffic being generated from or coming to me from. I can flip this to say, well, which ISPs are the loudest or the ones that are talking to me the most. And if I look for an example, we can do a little bit of a threat hunting activity by simply pivoting over to a user and start looking at the different users that are touching our applications and information around them. And this will really kind of drive us to the point of the 4 pillars because we're taking this single credential that may or may not be compromised, but certainly is known, and look at all of the activity that's happening on that one credential. Apparently, this person has 5 different user agents. They're coming from 1,000 different IPs, different geo distributions, different countries, etc. And so you can tell that this is a credential that's being used by a bot that's attempting to hit a bunch of different endpoints of ours. And we can see that they're hitting various API endpoints as well as they're trying to log in and they're probably trying to take over this account. We often see this in account takeover where one account is coming from all different places and it's hitting the same login API endpoint. And the reason why it looks like this is the bot is testing this user against that endpoint, but they don't want to set alarms off. So they're rotating through probably a bulletproof proxy network and allowing themselves to look like they're coming from all over the place. But of course, if you're monitoring an end user, you know that they're going to be coming from a single IP for quite some time, and then they're maybe going to change IPs and they're going to come from that single IP for another block of time. If they rotate really quickly through the IPs, something's up. And we track that behavior, and one of our machine learning models understands exactly what's going on there and makes an attempt to flag that behavior, and then we send it off to the mitigator, which allows for us to cut down on it. So in order to sort of illustrate this, we're going to work this as if a case has come into support and somebody is complaining that they're seeing a bunch of login attempts against their username, and they're probably generating emails that say either you're resetting your password or click this link to reset your password. If you didn't try this, contact support, etc. So what I'm going to do is just simply filter out one of these users. I'll grab an existing rule that maybe is here, and I'll just flip the different username inside of it. I'll say I want this filter to apply, and it's going to apply. So now I can see that I have this one user. It's had a whole bunch of events against the application. It's come from 1,000 different IPs, 322 different organizations out in the world. and is rotating through 5 user agents. And if you look at this global distribution of where everything is coming from, it's pretty easy to understand that this single user is not coming from all these different places. Even if they're using, one of those VPN solutions where you can sort of pick where your endpoint is, humans don't do this sort of thing. They don't go bouncing through the world with 5 different web browsers and try to do things like go against the authentication service. So it's pretty easy from this perspective and from the 4 pillars perspective to see that we can line up these pieces and understand that this is an attack that's coming against this organization, and they're attempting to hit the API layer. So you might ask yourself, well, if this is a single bot that's using this this one username, don't you think they're probably trying to go through a whole bunch of different usernames? And that's probably the case. So if we pull up some more details on this, we can drill into this threat a little bit further, and we can actually start hunting down where these attacks may be taking place. So as we scroll down through this information, we can see that this particular user, again, repeating the data, five user agents or 5 different browser types, 1,000 different IPs that this is coming from. And we start to roll down through here. And what we want to see is sort of uniqueness. And so you can see we're triggering on 2 different fingerprints. And if I want to go look for what else is happening against this fingerprint, I can. All I have to do is copy the fingerprint, go back to the dashboard, change my filter out. Instead of filtering on that username, I'm going to turn that one off, and I'm going to filter on a fingerprint, turn that on, and let the data rebuild. Now you can see that I built a list of usernames off to the left side here that are indicative of the same type of fingerprint and the same type of traffic. What this is a bot that's iterating through these usernames and iterating through a bunch of different IPs, attempting to authenticate. And we can see right away who the accounts are that were impacted by this, and we can probably create some kind of proactive outreach and let these customers know, hey, somebody's attempted to log into your credentials, please make sure your passwords are good, etc. So it's a really great way for you to generate the information off of authentication attempts, block them so that they don't work, and then also have kind of an educational piece to it to allow for you to notify your customers, hey, we're seeing a lot of attack traffic and somehow they got your username. One of the other things that we can do is sort of flip that over, and we can start looking at all of the fingerprints that are in here. What I'll do is just simply turn that filter off so that I'm looking at all of them. It's going to regenerate the data for me. And you can see our attack bot fingerprints that we have. And so there's a few different ones that are out there. If you select them, you can see what they're doing. Most of them are authentication related. So these are mostly account takeover type things. We do have some things like scraping or API enumeration, things like trying to figure out, are these accounts real? I recently wrote a blog post where I discussed what you can do in your APIs to make it a little less effective and efficient for an attacker to enumerate end users and passwords, etc. We can also see behavior in here for denial of inventory and seat spinning. If you look at where these all are coming from and what they're trying to do, is you can see that what's happening usually is you're seeing a spike of traffic that comes in that usually attempts to either take over inventory by tying up some kind of checkout process or tying up inventory in some way. Seat spinning is often referred to that because what happens is somebody will go get a list of credit cards. They'll purchase airline tickets with those credit cards, and then they'll resell those airline tickets to somebody else that legitimately wants to fly somewhere. And what they end up doing is committing a credit card fraud in order to tie up the inventory, and then they sell that inventory for a deep discount. So it feels like you're getting a good deal, but really what's happened is that seat was purchased with bad credit card. And oftentimes, if things go right for the attacker, when you give them your credit card to purchase the tickets, they just use that number to buy tickets additionally and sell those as well. So from account takeover, trying to get passwords reset and get the account taken over or understand where the accounts are, inventory takeover, and doing things like web scraping where I'm sending in single requests, it's possible to see exactly what's going on against your application, against your APIs, and allow for you to set up some mitigations. We have bot mitigations in a couple of different places. We can block on the firewall, and that does things like scanners and syntactically correct attacks that are going against a web application, as well as look at the API layer and build mitigations for attacks that are coming into those API layers. If you wanted to try our solution out against your application, all you have to do is give us a call, and we're happy to set that up. You just need to send us a little bit of traffic. It doesn't necessarily mean that you have to send us all of your traffic or span all of the traffic coming into an application. You can send us a little bit of it. We don't have to sit in line. We can sit off to the side, and we can really tell you what's happening inside of the application from a bot perspective. And it might, as I said before, give you a little bit of an operational advantage from a security perspective and allow for you to cut down on the amount of traffic that's actually going against the application that isn't legitimate.
Well, I hope you got something out of that. So in summary, we need to know what kind of attacks could be coming at us. We need to understand that if we are doing financial transactions, people want the money. If we're doing something else, people may want to take over accounts. So just really understand what the behavior might be, what the bots are trying to do. Bots are going to look like all the other traffic. The whole concept of hiding in plain sight means we see them coming after us, but they look like everyone else. And that's something that is difficult, and as I showed in the demo, you have to have a lot of data points in order to understand the transactional intent and understand how things are going to work. So I really appreciate everybody's time with this. I'm going to send it on back over to Thomas, who I think has a few questions for me.
I do indeed, Jason. Thank you. And folks, if you do have a question, just type it right into the Q&A box on your console. We have time for a couple here, Jason. First one, what should I be doing to protect my company from these types of attacks?
Well, one of the biggest things that anybody can do, and that is really easy to implement, is simply changing the way your error messages work. If I put in the wrong username, don't tell me that, right? If I put in the wrong password, also don't tell me that. Just say something went wrong and let the user decide what's going to happen there. Now, that's going to generate a little bit of user friction, but it's going to make it so that the attackers aren't so well equipped to attack you.
How about this one? Isn't credential stuffing really related to the user not using a good password?
Yes, and a lot of organizations sort of feel that way and look at it from that perspective. But realistically, an end user should be using a good password. There's no doubt there, but we know they're not going to. We know there's going to be rampant password reuse. Password vaults really haven't caught on with consumers. And so what we're going to have to do is make it so that we know they're going to use a bad password and implement something else. Like, for instance, my bank makes me use my phone, and it sends me a text message and multi-factor authentication there. They assume that I'm not going to have a good password, even though they try to put good limits in place, at least have 8 characters, letters and numbers, all that kind of thing. But you have to realize that in the end, the user is going to do the easiest thing. And so we have to try to work along those lines.
Good points, and all very illuminating. Well, that's about all the time we have for today's live webcast. I want to give a big thanks to our speaker, Jason Kent of Sequence Security, for his expertise and insights. And thanks especially to you, our listeners, for tuning in. Please remember to check out the additional resources tab of your player for links to some valuable Sequence security resources. And again, if we didn't get a chance to address your question during the webcast, we hope to get back to you with an answer within a few days. Also, you can email webinars@sequence.ai with any questions. Again, that's webinars@sequence.ai. For Sequence Security and IDG, I'm Tom Schmidt.
And I'm Jason Kent.